Bismillahirrahmanirrahim. Sallallahu alayhi wa sallam. Allahumma rabbi zidni ilma. Qalu subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Alhamdulillahi rabbil alamin. Sallallahu alayhi wa sallam. Ameen. We should be polite to others. Integration lecture 2. In this lecture I will discuss the integration of these functions: exponential, logarithmic, trigonometric, inverse trigonometric. I will discuss the integration of inverse trigonometric in my next lecture. And I will also discuss the basic formulae and the integration of even and odd powers of sine and cos in this lecture. So let's begin with the integration of these functions. Integration of exponential functions. Well, to integrate exponential function, we must know how to differentiate exponential function, because integration is the reverse process of differentiation. If we know the differential of e, if we know how to differentiate e, then we can easily integrate e. So this is the way to differentiate e. We copy e and then we multiply e with the differential of its power. The differential of the power of this e is 3. So this is the way we differentiate exponential. Now in integration we do the reverse thing, the opposite thing. We copy exponential here and then we divide exponential by the differential of its power. Here we multiply exponential with the differential of its power, whereas in integration we divide the exponential with the differential of its power. So in this way you can easily learn the integration of exponential function. ln functions. We know the differential of ln x, it's 1 upon x. The differential of ln x is 1 upon x. What if we have d upon dx ln ax plus b? Then the differential of this ln will be 1 upon ax plus b times a. This is the way to differentiate ln functions. Now to integrate ln x, we use integration by parts, because the direct integral of ln x is not available. So we cannot integrate ln x directly. To integrate ln, we use integration by parts, and I will discuss this method in my next lecture. So I'm leaving the integration of ln x in this lecture. Well, algebraic functions. You all know how to integrate algebraic functions because you have done this in your P1 syllabus. And ADMAth students know how to integrate because they have done this in ADMAth as well. Well, this is the simple algebraic function. We just add 1 in power and we divide function by the resultant power, and we write constant of integration, and this formula is true for all values of n except -1. For -1 we have a different formula. I will discuss that formula in my lecture. And you all know this is the composite linear algebraic function, this one. Composite linear algebraic function. And the most important thing, when the function is linear, then its differential is constant. Basically differentials are of two types. I will discuss this thing later in this lecture. So we can easily integrate this. You have done this in P1 syllabus. So you just need to add 1 in power, divide this function by the resultant power, and most important thing, multiply this n plus 1 with the differential of the function. The differential of ax plus b is a. So make sure you multiply n plus 1 with the differential of the function. This is the way we integrate the simple linear composite algebraic function. Now what if a power is -1? So how to integrate this function? Well, first you need to bring this function in denominator. You cannot integrate this function in numerator, because if you will integrate this function in numerator, then this function will become infinite. See, x minus 1 dx. If I will use this method to integrate this function, then I will get 0 here. This is 0 and the entire thing is infinite. So never you integrate function when the function has power minus 1 in numerator. Always bring the function in denominator first and then integrate it. Now how to integrate this function? Now this is very important. Well, we can easily integrate this function by using this rule. See, since integration is the reverse process of differentiation, so when we differentiate ln x, we get 1 upon x. Hence, when we will integrate 1 upon x, we must get ln x. So we will use this concept to integrate the 1 upon x function, the function which has power 1 in denominator. So this will become ln x plus c. This 1 upon x will become ln x plus c. And make sure you write modulus whenever you write ln in the integral, like in answer. Since we integrate 1 upon x by using ln x concept, so always use modulus for ln function, because ln is defined for positive values. So when n is -1, then bring the function in denominator and use this concept to integrate the function. Now, integration of trigonometric functions. Now this is very important. This is the integration of sine power 1. So we know how to differentiate sine power 1 3x. So this will become cos 3x times 3. And the answer is positive. And since integration is the reverse, therefore, when we will integrate sine, the answer must be negative. This is negative. The integral of sine is negative, and we divide function by the differential of its angle. The differential of the angle is 3, so divide function by 3. In differentiation, we multiply function by the differential of its angle. So in integration, we divide function by the differential of its angle. Make sure you remember this rule. Now integration of cos 3x. So before integrating cos function, we should know the differential of cos 3. So the differential of cos is negative sine 3x times 3. Therefore, its integral would be sine 3x upon 3 plus c. Now, the differential of tan 3x is sec square 3x times 3. Therefore, the integral of sec square must be tan. So when we will integrate sec square 3x, we will get tan 3x upon 3. And one very important rule to understand the negative sign here and here. So you can learn these negative signs. So in differentiation, I'm talking about differentiation. In differentiation, when question starts with the letter C, then there is a negative sign in the answer. This is the rule to learn negative sign in differentiation. I'm repeating, in differentiation, if the question starts with the letter C, then there is a negative sign in the answer. This is the way to learn the negative sign in differentiation. In integration, if the answer starts with the letter C, then there is a negative sign in the answer. Let me repeat this. In integration, if the answer starts with the letter C, then there is a negative sign in the answer. This rule is here. In integration, when answer starts with the letter C, then there is a negative sign in the answer. I will discuss the integration of these two functions, tan power 1 3x and cot power 1 3x, after explaining the basic formula number 2, because these two integrations are based on this formula. Now, basic formula number 1. We use this formula in partial fractions and products of sine and cos, like this. And what's the formula? The formula is, let me change the color of the pencil. Now, this is the formula, basic formula number 1. This is true for all values of n except -1. So, in this formula, this is the function f of x has power 1n, and its differential is multiplying with dx. This is the important thing. So when the differential of the function is multiplying with dx, then to integrate the function, we just add 1 in power and divide the function by the resultant power. This is the way to integrate the function. So when differential is multiplying, then we copy the function, we add just 1 in power, and we divide function by the resultant power. Now let me explain this formula by the following examples. Example B. So in this example, see, this is the function x square plus 4. If you will differentiate this function mentally, you will get 2x. And this 2x is basically differential of this function. So according to basic formula number 1, when differential is multiplying with the integral operator, then we just add 1 in power and we divide the function by the resultant power. This is the way to integrate the function when the complete differential is multiplying with dx. What if the differential is incomplete? Like in this example. Sorry. Well, if you will differentiate this function mentally, you will get x. Let me differentiate this here. X square plus 4. When you will differentiate x square plus 4, you will get 2x. So, according to basic formula number 1, we must have differential, complete differential here. So, since we don't have the complete differential, something is missing in this differential, which is 2. And the most important thing is 2 is constant. So, according to basic formula number 1, if complete differential is not multiplying with dx, and if constant is missing in the differential, then you can still use basic formula number 1. So basic formula 1 can be used in two situations. Situation number 1, when the complete differential is there, like in this example, you can easily use basic formula number 1. This is the complete differential. When there is an incomplete differential, like this one is incomplete differential, this x. So make sure the differential in differential constant is missing. So if constant is missing in the differential, then you can still use basic formula number 1, because you can divide function by constant. So this 2 is missing in the differential, therefore you just need to divide this function with the differential 2. This 6 is of the power. You know how to get the 6 here. So make sure you will use basic formula in two cases. Case number 1, if complete differential is there, like in this example, use basic formula number 1 easily. When the differential is incomplete but constant is missing in the differential. The most important thing, constant must be missing, not variable. Then you can still use basic formula 1 because you can divide function by constant. Let me write this here. We can divide the function. You can divide function, in fact. You can divide any function by the constant. So, but if variable is missing in differential, then you can never use this formula, basic formula number 1. So make sure you must not use basic formula 1 if the variable is missing in the differential. So if you observe this carefully, you will see the differential is 2x and x is missing. 2 is there, but x is missing. Now this is very important. X is variable. And you know variable can take any value including 0. So we never divide function by variable. This is the basic rule of maths. So we can never use basic formula 1 here. That is why I wrote not equal sign. Don't use basic formula 1 to integrate this type of function because variable is missing in differential. Now differentials are of two types. This is very important. This is one of the most important concepts in integration especially. Note, differentials are of two types, constant and variable. In integration, we never divide functions by the variable differentials because variable can take any value including 0. But we can divide, we always divide in fact, functions by the constants, that is constant differentials, because there is no problem by dividing the constants, function by constants. More examples of basic formula number 1. I told you we use basic formula to integrate the products of sine and cos. This is the product of sine and cos. Now you need to understand the function which has power 1 is the differential and the other thing is function. I mean, there are two functions, sine and cos. Now you need to observe which one is function and which one is differential. The differential will always has power 1 because the function has other power. Sine theta has power 2. This will never be differential of cos. So make sure you identify the differential carefully. The differential has power 1 always. So this is the differential of this sine theta. Now you just need to differentiate sine 3 theta mentally. I'm writing here to make it easy for all of you. The differential of sine 3 theta is 3 cos 3 theta. Now you need to observe the differential carefully. Something is missing in this differential. So this 3 is missing. So 3 is missing in the differential and 3 is constant. So no problem, we can use basic formula number 1 here. So this is the way to use basic formula. Add 1 in power, divide sine 3 theta power 3 by the resultant power and multiply the resultant power with the differential of the function. This 3 was missing, so this 3 is for the missing differential, and this 3 is for the resultant power. Next example, cos. Now this is the differential of this function. Now you need to differentiate cos 6 theta mentally. When you will differentiate cos 6 theta, you will get minus 6 sine 6 theta. So minus 6 is missing in this differential. So you can easily use basic formula 1 here. Add 1 in power, divide this function by the resultant power and with the missing differential. This minus 6 is for the missing differential. This 3 is for the resultant power. Another example of basic formula number 1. Since the power of the function is not 1, so bring this function in numerator. Remember this rule. If the power of the function, when the function is in denominator, is not 1, then always bring the function in numerator. What if we had this function? 2x, x square plus 3 power 1. So when the power of the function is 1, then never bring the function in numerator. If the power is anything except 1, always bring the function in numerator. Like in this case, you need to bring this here. So make sure you observe the function carefully. So let me repeat this. If the power of the function is 1, then never bring the function in numerator. Leave the function in denominator. But when the power is anything except 1 and the function is in denominator, then always bring the function in numerator, like this. Now check the differential of this bracket. This is the function. The differential of this function is 2x, and it's the complete differential, fortunately. So we can easily integrate this function by adding 1 in power and dividing this function by the resultant power. Now this is the simplified form of this question, this answer. Basic formula number 2. Now let me discuss basic formula number 2. We use this formula in partial fractions and in fractions of sine and cos. And this formula is only applicable when the power of the function is minus 1 in numerator or 1 in denominator. Now, this is the formula. And this formula works according to this rule. So, according to this formula, basic formula number 2, the power of the function must be 1 and the function is in denominator. So, and its differential must be multiplying with dx. So, when we have this type of situation, when the function is in denominator with power 1 and when its differential is multiplying with dx, we can easily integrate this function by writing ln function, this one, modulus plus c. And the logic of this integration is this. This is the logic. Why are we using ln in this? Because when we differentiate ln, we get 1 upon x. And integration is the reverse process of differentiation. Therefore, when we will integrate 1 upon x, we must get ln x. That's the logic. examples of this basic formula number 2. Let me start with this example. This is example number 1. So the most important thing is this power. Since the power of the function is 1 and the function is in denominator, therefore we have to use basic formula number 2. Now check the differential of this function mentally. The differential of this function is 2 and it is there with dx. Therefore we can easily integrate this function by using basic formula number 2, and according to basic formula number 2, the integral of this function will be ln times the function, but the function must be in modulus because ln is always defined for positive values. So make sure you always write modulus. Now see example number 2. If you see, the example is same, but differential is not in numerator right now in this example. The differential of this is 2 and 2 is not multiplying with dx. So basically 2 is missing in the differential, and luckily 2 is a constant, so we can integrate this function by using basic formula number 2. Therefore, according to basic formula number 2, the integration of this 1 upon 2x plus 5 will be ln modulus, and function is here, and we need to divide this entire thing by the differential of the function, this thing, because 2 was missing. Make sure variable must not be missing. If variable will be missing, then we can never use neither basic formula number 1 nor basic formula number 2. Now see example number 3. In example number 3, if you will see, the differential of this is 2x. Fortunately, we have variable and constant is missing. So we can again use basic formula number 2. We just need to divide ln x square plus 4 by 2. Now let me discuss this example. Example number 4. Now this is very important. What if we had this thing? Can we use basic formula number 2 here? For that we need to check the differential of denominator first. The differential of the denominator is 2x. Now according to this 2, x is missing. In the differential. So when variable is missing in the differential, we can never use basic formula number 2. So we can never solve this question by this basic formula 2 method. This is the wrong way. Because we can never divide functions by variable. So never use basic formula 1 and 2 when variable differentials are missing. Now tan 3x. To tan power 1 3x, in fact. The most important thing is power 1. Because tan square 3x can easily be integrated. We can easily integrate tan square 3x as this. We should use identity because we know the differential of sec square x is available. It's tan 3x upon 3 minus x plus c. So tan square 3x is not a problem. You can easily integrate this. But the problem is tan power 1 3x. Now this is very important. When we have power 1 of tan, then we have to use basic formula number 2 to integrate this function. Now how to integrate this function? First you need to write tan 3x in the form of sine and cos. So tan can be written as sine 3x over cos 3x. Now according to basic formula number 2 structure, the function is in denominator and its differential must be multiplying with dx in numerator. So if you differentiate cos 3x mentally, you will see the differential of cos 3x will be minus 3 sine 3x. So something is still missing in the differential, and which is minus 3. And fortunately, this thing is constant. So we can integrate this ln cos by writing ln cos 3x, but make sure you will divide this entire thing by the differential of this function. This equal should be here, not here. And you know how to get this sec. This is very simple. To get sec, you need to bring this minus here, and then you need to bring this minus here. And you must know that cos 3x power minus 1 is basically sec 3x. That is, this is the way, and this is the logic of getting sec 3x here. But you can leave your question, your answer here. This is perfectly fine, because if you would need the value of c, you will substitute cos in your calculator, not sec in your calculator. So this is fine, but if it is required in the exam that you have to show this thing, so you must know how to get sec, and this is the way to get sec. Now integration of cot 3x, same thing, the power is 1, like in tan case. So when the power of cot is 1, then you need to write cot as a fraction of sine and cos. And according to basic formula number 2, this is the differential. This is the function, and its differential is this. But if you will observe cos 3x, something is still missing in the differential, which is 3. 3 is missing in the differential. If someone is weak in differentials, then he would think, how would I say that 3 is missing? Because if you know the differential of sine, it is this sine, it will be 3 cos 3x. So see, this 3 is missing. So you need to divide your answer ln sine 3x by this 3. This is a way to integrate cot power 1 3x. And this is the application of basic formula number 2, the best application of basic formula number 2. Well, I will discuss the integration of odd powers of sine and cos and even powers of sine and cos in my next lecture, inshallah. So this is all for this lecture. This is the advice for me and for everyone. The beauty of life is in good manners. We should have good manners. We should strive for the good manners, to have good manners. Allah Hafiz.